Hi dear friends and viewers, welcome back to our channel Anvinay Kumar Basics of Physics. Dear friends, in this video we are going to discuss about the what is coefficient of viscosity and what is Stoke's law and how we can find out the terminal velocity of the body when it is passing through a fluid by using the Stoke's law. Let's go for that, children. If you want to get the total content very clearly, for that you have to watch the video up to last without any skip. So without late, we are going to the topic. So children, after watching the video, if you can like it, if you can understand the topic, just like, share, comment the video and subscribe our channel too. Okay, without late, we are going to the topic. What is mean by coefficient of viscosity? So first you have to know idea about the what is viscous force. Viscous force is nothing but the frictional force acting between the fluid layers. That should be what we call viscous force. So what we know in the previous chapters we discussed about the frictional force. What is frictional force? A tangential, for example here it is the one horizontal surface. On that surface some body it is there. If we can apply some force, then in opposite direction some frictional force is acting. Clear? The tangential force acting between two bodies, and there should be opposite motion of the body, that is what we call frictional force. We applied some force, due to that the body will move, and the frictional force must be always tries to oppose the moving of the object. Clear? That is the frictional force what we know. The same thing here. Now if we can take, it is the fluid, and just imagine, we are imagining that these are the fluid layers. Clear? So here if you have to observe these two, one first layer and second layer, from top to bottom I am saying now. Here the first layer is moving in this direction, second also moving in the same direction, but the second layer will apply some force in opposite direction of the first one, where they are in contact. Here this is the first layer and this is the second layer. Here this is the point of contact of those two layers. The bottom layer will oppose the motion of the top one. Due to that there is some frictional force is created between these two, that is what we call viscous force. What we call viscous. What is viscous force? Frictional force acting between two fluid layers. That should be what we call frictional force. What we call viscous force. That frictional force is what it is? Nothing but viscous force. Frictional force acting between two fluid layers is called viscous force, and the bottom layer will oppose the velocity of top one. The bottom layer is always tries to decreases the velocity of the top one. That is what we call, children, viscous force. It is quite similar to the frictional force what we discussed when the two objects are in contact, like that. So now here the topic it is given in our textbook as 8 marks question. In that the first thing is here, define coefficient of viscosity. Here coefficient of viscosity should be defined like this. Here this is the fluid layer, and coefficient of viscosity is shown like this. Neta is equals to F by A by delta V by delta X. This is the formula for coefficient of viscosity. Clear? From that formula we have to define frictional force or the force. The frictional force or viscous force. The viscous force acting on particular area, acting on particular area per unit velocity gradient is called coefficient of viscosity. Children. The viscous force acting on particular area per unit velocity gradient is called coefficient of viscosity. Here children, now these are the number of layers. In particular one layer or particular area, there is a frictional force acting between the layers. That should be here. We are writing eta x equals to F by A by delta V by delta x. Here delta V is the change in velocity and delta x is the length. So this is what we call children velocity gradient. The velocity available in particular distance, that should be what we call velocity gradient. Simply velocity for length is called velocity gradient. Clear? So here what I have to write? What I have to record this definition, what it is? Delta V by delta x is 1 and F by A means what? Viscous force acting on particular area per unit velocity gradient. That means simply here delta V by delta x value is 1 we are taken, then eta is equals to F by A. So this is simply about the definition of coefficient of viscosity. The viscous force acting on particular area per unit velocity gradient is called coefficient of viscosity. For that, in examination you have to write the units and dimensional formula. So children, first thing is delta V by delta x. What is delta V by delta x? Delta V is the change in velocity. That means that should be having some dimension formula is LT inverse 1. And delta x is what? Length. So here we will get delta V by delta x means what? We get T inverse 1. And next here F by A. So F is what? M L T inverse 2 by L square. Then what you get here? M L inverse 1 T inverse 2. So that is the dimension formula of F by A, and D inverse 1 is the dimension formula of delta V by delta x. So now you can write dimension formula for coefficient of viscosity. F by A means what? M L inverse 1 T inverse 2 by delta V by delta x, what it is? T inverse 1. Children. Then eta is equals to what, right? M L inverse 1 T inverse 2 T. Then what to write? M L inverse 1 T inverse 2 plus 1. Yes. So M L inverse 1 T inverse 1 is the dimension formula of coefficient of viscosity. And children, now here units is what? Poise or Poisson. So coefficient of viscosity units what? Poise, and dimension formula is what? M L inverse 1 T inverse 1. So now children, we discuss about the what is Stokes law and how we can find out the terminal velocity. Let's see how we can find out the the terminal velocity by using Stokes law. First you have to know about the what is terminal velocity. So dear students, here it is the fluid. Thus we having so many layers, and in that fluid we are dropping one sphere. It is a metal sphere that should be having some radius r. Clear? We are taking some fluid. In that fluid we are going to drop the one metal sphere. While a metal sphere is dropped into the fluid, while it goes down, it will drag some liquid along with the sphere. Clear? When a sphere is immersed or sinked, when we drop some iron sphere into the fluid of a container, what you can observe? while it goes down, it will drag liquid along with the particular sphere. Due to that, what I have to say, there is some viscous force is acting. Clear? That viscous force is acting in upward direction. In upward direction means what? When the sphere goes down, the fluid is tries to moves the sphere in upward direction. In upward direction. That's why here, when the sphere is moving downwards, some viscous force is acting on the metal sphere. At the same time, what we know, children, when the sphere goes down, it will displace some water or fluid, water maybe. Either it is oil, water, fluid, anything what we are taking in the container. Clear? So while the bobbies goes down, it should be displaces some liquid. That liquid again comes to the sphere and should be applies the force in upward direction. That is what I have to say. Some buoyancy force is acting. Buoyancy force is acting in upward direction. Even though viscous force is acting on the body and buoyancy force is acting on the body, again the body goes down. It means that some weight it is there. The weight is dominating the viscous force and that particular buoyancy force. That's why it goes down. Clear? After moving some distance, the body will gain some constant velocity. With the constant velocity, the ship goes down. That particular velocity, what we call terminal velocity. Clear? Simply how to remember, when a metal sphere is dropped into the fluid, initially the ship be moving with variable velocities. After moving some distance, that will gain some constant velocity. That particular constant velocity is called terminal velocity. Clear, children? Now here, while it goes down like this. Clear? So here I am saying, now here to here that should be having some variable velocity. From at this point that should be moving with some constant velocity. That constant velocity, what we are saying, terminal velocity. So terminal velocity. Now let us see here when the terminal velocity will gain. So here, children, first thing is when the bob is in the fluid. When the bob is in the fluid, in upward directions, some forces are acting. One is the viscous force and next one is the buoyancy force, and finally it is weight. Clear? When a metal sphere of radius is passing through the fluid, on that sphere some viscous force, buoyancy force and weight are acting. The viscous force is depend upon the size of the sphere. Size of the sphere. If the size is more, it will drag the more liquid and viscous force is more. Clear? So at this case, children, here now when this Fv plus Fb is equals to W, that means upward force is equals to the downward force. Then the body will move with the constant velocity. That velocity what we call terminal velocity. Terminal velocity, children. Got it? So now here, according to Stoke's law, viscous force is directly proportional to the velocity of moving of the sphere. With what velocity that is going to be seen? That is what you take, V. So viscous force is directly proportional to the that one. And next, viscous force is directly proportional to the radius. Clear? And finally we can write F is equals to 6 pi neta into R into V. Viscous force is directly proportional to velocity of the body or sphere and directly proportional to the radius and directly proportional to the coefficient of viscosity. Simply here, according to Stoke's law, right, F is proportional to V and F is proportional to R and F is proportional to neta. From that what, right? F is equals to 6 pi neta into R into V. So that is the children here viscous force acting on the sphere when it is passing through the fluid. So here in that equation what is, this is the viscous force that should be given by this equation. Clear children? So this is about the viscous force acting on the body. So children, we need some space, that's why I am erasing this one. So as early as possible you have to pause the video and try to copy the notes. Clear? And next children, here when the body is passing through the sphere, passing through the fluid, that should be having what is buoyancy force is there. And what is W? W is the weight. So in this case, W is equals to what, right? W is equals to, here we can write mg. W is what? mg. What is m? Mass of the sphere. And what is g? Acceleration due to gravity. And how is the sphere? It is like a sphere, like a metal sphere like this. That's why its volume is what? 4/3 pi r cube. 4/3 pi r cube. That's why here children, the weight should be written as, here W is equals to mass into, here what we know, rho is equals to what? Mass per volume. Then mass what we write? Rho into V. Density into volume we can write. That's why here instead of m I am going to write W is equals to, here children, rho into, here V is what? 4/3 pi r cube. 4/3 pi r cube and to G. Rho into volume is what? Mass. And G is the acceleration due to gravity. Here what is rho? Rho is the density of the sphere. Density of the sphere. Density of sphere. That's what right here. W is equals to 4/3 pi r cube rho G. It is the weight of the sphere when it is passes through the fluid. So in the same manner children, here buoyancy force or upward thrust, simply what we say, upward thrust or buoyancy force. Buoyancy force also written as same manner. That should be here FB. I am going to say that is what, same here, 4/3 pi r cube sigma into G. Sigma into G. Here what is R? R is the radius of the metal sphere and sigma is the density of the fluid. What it is? Density of the fluid. Clear? So children, we have now three equations are there. Already I told you what it is. When the body is in the fluid, upward force is what? Viscous force. And next one is what? Buoyancy force. And that should be equals to what? Weight. When upward force is equals to the downward force, then that should be moving with constant velocity. That velocity what we have called? Terminal velocity. That's why instead of V, what you have to write? Vt you have to take. That's why here now in that formula you have to substitute Fb plus Fb is equals to W. What is Fb children? This one, 6 pi neta R Vt is equals to R plus Fb plus Fb. What is Fb value? 4/3 pi r cube rho sigma into G is equals to what? W value. What is W value? This one only, 4/3 r cube rho Z. That's what we have, 4/3 pi r cube rho into G. So from those equations, what we are children here now? 6 pi neta r Vt is equals to, you can take this term that side, then what you get? 4/3 pi r cube rho G minus 4/3 pi r cube sigma into G. Here it is plus, if it is come to this side, minus. So now here what, right? 6 pi neta r Vt is equals to, in this which is common here, 4/3 pi r cube into G is common, rho minus sigma. Rho minus sigma. What is rho? Density of the sphere. What is sigma? Density of the fluid. Now what you have to find out? Terminal velocity. That's why we write Vt is equals to 4/3 pi r cube into g of rho minus sigma by what you have. We want to keep here only V2, remaining we have to take that side. Then what you get? 6 pi neta r. Then what you get here? 4 pi r cube of g of rho minus sigma by 3 into 6 pi neta. What it is means 6 into 3, 18. 18 into pi neta into r. Here pi cancel. Then what you have? 2 2s are 2 9s are 2 9s are. Then what you get? Vt is equals to what? 2 by 9 of r cube g of rho minus sigma by neta into r. So this is the expression for terminal velocity. What did children? Expression what is? Vt is equals to 2 by 9 of r cube g of rho minus sigma by neta into r. So here r1s are 1's cancel. Then what you get? Vt is equals to what, right? 2 9 r square g of rho minus sigma by neta. So this is the expression for what? Terminal velocity. So this equation represents the terminal velocity, where terminal velocity of the body in fluid. Where did children? In fluid. And now you have to observe the children. Here g is the constant, rho is constant, sigma is constant, neta is constant. And now here what you have to say? Simply terminal velocity is depend upon the radius of the sphere. So dear students, this is about the Stokes law and coefficient of viscosity and terminal velocity expression derivation. So dear students, if you can understand this one, like, share, comment the video, and my request is, if you can understand this one, share our channel to your friends and help them to get the good subject. Thank you for watching.